All right, today we are cracking open a cosmic cold case, a galactic collision that went down billions of years ago. Our prime witness, this absolutely breathtaking city of stars called Messier 75. And get this, the key piece of evidence? A sausage. Yeah, I know what you're thinking. A sausage? In space? It sounds completely absurd, right? But believe it or not, this is one of the biggest clues we have to unraveling a huge secret about the Milky Way's pretty violent past. Let's dig in. So this Gaia sausage isn't something you'd find at a cosmic barbecue. It's actually the scene of a cosmic crime. You see, astronomers using the Gaia Space Telescope were tracking the movements of millions of stars when they found something really, really odd. There was this whole group of stars moving in a strange, super stretched out, sausage-like pattern. These stars weren't orbiting nicely. Nope. They were plunging in and out from the center of the galaxy on these extreme paths. And that is the unmistakable signature of a dwarf galaxy being literally eaten by our own Milky Way. But, just seeing a pattern of stars isn't quite enough. To really understand what happened in this merger, like when it happened, what that other galaxy was like, the cosmic investigators needed something more. They needed a survivor, a fossil from that collision that could testify to what went down. They needed a reliable witness. And that, my friends, brings us to our star witness, Messier 75. It's what's called a globular cluster, basically a dense, ancient ball of about 400,000 stars, hanging out over 60,000 light-years away from us in the constellation Sagittarius. It's one of the most jam-packed clusters we know of, and as we're about to find out, it has quite the story to tell. Now, to properly interrogate a star cluster, you have to look at it in different ways. On the left, in normal visible light, the center of M75 is just this crowded, washed-out mess of bright, cool red giant stars. But when we switch over to ultraviolet light on the right, whoa, those giants just fade away, and suddenly they reveal this hidden population of super hot, energetic stars. And studying those hidden stars, well, that's the key to unlocking this cluster's secrets. So the very first piece of evidence isn't even what's inside the cluster. It's all about how the cluster itself is moving. This is our first major clue to where it came from. And this brings us to a really crucial number, 0.87. That is the eccentricity of M75's orbit. Now, to put that in perspective, an orbit with an eccentricity of 0 is a perfect circle. So a value of 0.87, that is a wildly stretched out, super elongated orbit. M75 isn't just circling the galaxy, it is plunging through it. And here's why that matters. Objects that were actually born inside the Milky Way tend to go with the flow, They follow these relatively neat circular paths. But M75's orbit is chaotic. It's exactly what you'd expect to see from something that was captured during a violent galactic merger. Its orbit basically screams, I am not from around here. And hey, this isn't just me speculating. The research paper puts it pretty plainly. An accretion origin cannot be excluded. In science speak, accretion just means it was captured from another galaxy. So the orbit itself is basically a confession, but that's just the first clue. Okay, we've looked at its orbit. Now let's peer inside the cluster, at the stars themselves. Because if M75 really did come from another galaxy, its stellar population should also look pretty different from our native stars. And oh boy, does it ever. First up, we've got these bizarre characters called blue stragglers. In an ancient cluster like this, all the really massive stars should have died a long, long time ago. But these guys are heavy and they look suspiciously young. They're like stellar zombies, old stars that have kind of come back to life by merging with or siphoning off material from a companion star. This chart shows just how unusual this is. That gray band there represents the normal frequency of these blue stragglers and other clusters. And those black dots? That's M75. Its core has one of the highest concentrations of these things ever seen. And because these zombie stars are so heavy, they've all sunk to the center. It's a process called mass segregation. This extreme pileup is a huge flashing sign that this cluster has had a really turbulent past. But the oddities don't stop there. M75 is also home to a strange population of pulsating stars called RR Lyrae variables. Think of them as cosmic heartbeats. Now, most clusters in the Milky Way fall neatly into one of two groups, based on the rhythm of these heartbeats. But M75 stars? They pulse at this weird intermediate rate. This gets it a rare classification, Oosterhoff intermediate, which sets it apart yet again from our native Milky Way clusters. It's just another piece of evidence that this witness isn't from around here. So, we have cross-examined the witness, we've analyzed its movements, and we've studied its internal character. I think it's time to bring all the evidence together and deliver the verdict. And honestly, the case is overwhelming. We've got its motion, which puts it squarely in that sausage group of objects. We have its highly eccentric orbit, a dead giveaway. Research also shows it's a slow rotator, which is not at all like typical Milky Way clusters. And finally, you have its bizarre internal populations, that overabundance of blue stragglers and the strangely pulsating RR Lyrae stars. It all points to a different origin. The verdict is in. Messier 75 is an immigrant. It is a surviving relic, a fossil from the core of that Gaia sausage dwarf galaxy that was torn apart and consumed by our Milky Way billions of years ago. It literally witnessed the death of its home galaxy. It's a really fascinating detective story, for sure. But what's the bigger picture here? I mean, why does proving one little star cluster is an immigrant actually matter? Because it confirms that our own home, the Milky Way, is not some pristine island in space. Oh no, it's a cosmic cannibal. It was built piece by piece, merger by merger, from countless other smaller galaxies, just like the Gaia saucer. And witnesses like Messier 75 are the living proof, showing us that our galaxy's story is one of violent, beautiful, and constant transformation. Our galaxy is, itself, a nation of cosmic immigrants,